Okay, here's the recording in progress. All right, so we were here. I was actually already done with 4.5. So we're going on to 4.6 now. And I'm not really that far ahead because I forgot to put 4.9 here. Okay, so starting 4.6. If I have time left over, I'll let you ask questions about 4.5, but we'll see how it goes. Okay, get a quiz tomorrow. Quiz Friday the 29th, and then the next exam is November the 5th, it looks like. Okay. All right, so let's get started on the next section, which is on the other trig functions. Other trigonometric functions, page 231. Even though it says the other trigonometric functions, we're still heavily dependent on sine, cosine, and tangent. Okay, so these identities, I'm sure you've seen it before in trig. Tangent is sine over cosine. Secant is the reciprocal of the cosine. Cotangent is cosine over sine. Cosecant is 1 over the sine. If you want to put those on your cheat sheet, you may. This is sort of what I said before on page 232. All students take calculus. You don't have to remember all students take calculus, but for sine, cosine, and tangent, they're all positive. Only the sine is positive, only the tangent is positive, only the cosine is positive. That's equivalent to what they have here. You say, where's tangent? Well, tangent is the ratio of the sine to the cosine. So you either get positive divided by positive, or positive divided by negative, or negative divided by positive, and all that stuff. That gives you the tangent. Okay, so you can put that in your formula sheet if you wish also. Okay. We'll eventually get to graphs of the trig functions if you want to see them rapidly. So page 234, here's a basic graph of tangent. And I'll develop that eventually. And we have the graph of page 236, cosecant in red, secant in red, and cotangent in blue, it looks like. Yeah, cotangent. All right, so let's see what I need to show you in the text. So we're here. 1 to 6 all, 7 to 35 odd. Okay, so 1 to 6 all. 237. Here's 1 through 6 all, ALL. So I'll do the even ones. The odd answers in the back of the book. And 7 through 35. Complete a table here. Whoops. Hopefully that's readable. And that, and sketch some curves. And I think you can see everything from there. Okay. All right, so find a quadrant where the given conditions are satisfied. Okay, 2. Tangent is negative, cosine is negative. Tangent negative, cosine negative. Second quadrant, right? Only the sine is positive. So this is quadrant 2. Okay, 4. Secant positive, tangent negative. Okay, now you might recall one of the properties of reciprocals. If a function is positive, the reciprocal is positive. If a function is negative, the reciprocal is negative. So we're trying to piggyback on our rules about reciprocals. So what's the reciprocal of secant cosine? Okay. If a function is positive, its reciprocal is positive. Like the reciprocal of 7 is 1/7. The reciprocal of -2 is -1/2. So if a function is positive, when you flip it, it's still positive. If it's negative, when you flip it, it's still negative. Okay, so I think cosine positive, tangent negative. Cosine positive, tangent negative is quadrant 4. What happened there? I lost the shared screen for some reason. Let's see if I can get it back. Okay, I'm back. So that's quadrant 4. All right, number 6, sine negative, secant negative. What's the reciprocal of the secant? Cosine. Remember, if one trig function has a co, the reciprocal does not have a co. So reciprocal of secant is cosine. Secant negative means cosine is negative. Sine and cosine are both negative. Sine and cosine are both negative. That's quadrant 3. So that takes care of 1 through 6. I did the evens, and 1, 3, and 5, you got the answers in the back of the book theoretically. Okay. 7, complete the table. It looks like it can be really long. Okay. But if you think of your analysis of your unit circle, hopefully you can figure it out. I was going to show you 7 pi over 6 and 5 pi over 4. You get the idea from the rest. All of these have a reference angle of either 30 degrees or 45 degrees. Okay, so use the principle. If the reference angle is 45 degrees, automatically both x and y are plus or minus radical 2 over 2. If the reference angle is 30 or 60 degrees, which would be pi over 6 or pi over 3 radians, one of the coordinates is either plus or minus 1/2. If you draw a unit circle, you can usually tell. And what's paired with plus or minus 1/2? It's always plus or minus radical 3 over 2. Okay, so let me try to show you one of those. So number 7, 7 pi over 6. Remember, when you have radians, you can always change it to degrees if it makes you more comfortable. So here I multiply by 180 over pi. Pi cancels out. 180 divided by 6 is 30. 30 times 7 is 210. So 210 degrees, that's right over here. Third quadrant. Okay, 30 degrees down. Now, what's all this line stuff? I like to do this because that way I can tell, is the x or the y coordinate halfway across the circle. Okay, so if we look here at x, that's way more than half. That looks like it's halfway down. So I'm going to say the y coordinate is -1/2, third quadrant, which means the x is automatically negative radical 3 over 2. Okay. For any angle that has a reference angle of 30 or 60, you can play that same game. Draw the angle. Ask yourself, is x or y halfway across the circle? Once you get plus or minus 1/2, the other is automatically plus or minus radical 3 over 2. Okay. Now I can fill out the table as necessary. So cosine means x coordinate, negative radical 3 over 2. Sine means y coordinate, -1/2. Tangent is sine over cosine, -1/2 divided by negative radical 3 over 2. 2 negatives make a positive. Okay. This theme will happen a lot. See this 2 here and this 2 here? You just cross them out. If you're dividing top and bottom by the same thing, you're allowed to cross them off. So in other words, you can just cross off that 2, cross off that 2. So I have 1 over radical 3. If you wish to rationalize the denominator, you can call it radical 3 over 3. But if you leave it as 1 over radical 3, that's okay by me. Okay, by the way, the justification of just knocking off the 2's, well, if you can multiply top and bottom by 2, that'll do it. Multiply by 2 over 2, 2 over 2, that cancels. 2 over 2, that cancels. And so we just have that. That's a recurring theme from trig. Maybe you saw that from your trig class, that if you ever divide both the numerator and the denominator by the same thing. Like if there's a divided by 7 and this is divided by 7, you can just lose the 7s, but they have to be the same number. Okay. And then it looks like after that, all I have are just the reciprocal functions. So I just reciprocate. So secant is the reciprocal of the cosine. So flip that, -2 over radical 3. I will accept that. But if you want to go ahead and rationalize the denominator, -2 radical 3 over 3, that's okay. Cosecant, flip that, -2. Cotangent, flip that, radical 3. And see, here's where I prefer to have it 1 over radical 3. If you flip it, it's radical 3 over 1. But if you flip that, you got to do a little bit more work. So there we go. Okay, 5 pi over 4. Where is 5 pi over 4? Pi over 4, 2 pi over 4, 3, 4, 5 pi over 4. I'm in quadrant 3 again. And since the reference angle is 45 degrees, automatically radical 2 over 2 for both x and y. And since we're in quadrant 3, they're both negative. Okay. So if you understand those principles, you can go all the way around the circle and get all these things. Okay. You pretty much do the same stuff. Okay, cosine, x-coordinate, negative radical 2 over 2. Sine of 5 pi over 4, same thing. Tangent is the ratio of these two. Well, anything divided by itself is automatically 1. Secant, well, if you flip cosine, you get -2 over radical 2. This comes out to be negative radical 2. So here's a case where you should actually go farther. This is much simpler than this. Here's the analysis. -2 over radical 2. If you multiply top and bottom by radical 2, this becomes a 2, right? So that 2 will cancel that 2. I have negative radical 2. Similarly, cosecant, also negative radical 2. And cotangent, well, you flip the tangent, but the reciprocal of 1 is 1. Just remember, x comma y is cosine theta sine theta. Okay. Okay, I will do 3 pi over 2 for you. So 3 pi over 2 over here. 3 pi over 2 is 270 degrees. That's down here. What is this ordered pair? 0, -1. So cosine 3 pi over 2, x-coordinate, 0. Sine of 3 pi over 2, y-coordinate, -1. Tangent, sine over cosine, so -1 divided by 0, undefined. Then I flip. Secant of 3 pi over 2, reciprocal of 0, undefined. Cosecant, flip sine. What's the reciprocal of -1? 1 over -1, still -1. Cotangent, cosine over sine, 0 divided by -1, 0. So we're good there. Okay, yeah, a little sidebar here. A over B divided by C over B. If you ever have something that like this, where the same thing is being divided here and here, if you multiply top and bottom by B over B, all the B's cancel out, so you just have A over C. Okay, so let's say you have 4 over 5 divided by 3 over 5, just cross off the 5s and just have 4 over 3 or whatever. All right, one more I was going to show you is 5 pi over 3. 5 pi over 3 is right over here somewhere. Okay, pi over 3, 2 pi over 3, 3, 4, 5 pi over 3, 6 pi over 3, 2 pi. So the reference angle is 60 degrees. So automatically either x or y is halfway across. Y is here, that looks like more than half. X is here, that seems halfway. So x gets the half, y automatically gets the radical 3/2. I'm in quadrant 4, so y is negative, x is positive. Okay. So if you play that game faithfully all the way through the circle, you can figure out any multiple of 45 degrees or multiply of 30, multiple of 30. Here I know it's a multiple of 30, so I know one of the coordinates is a half. Cosine 5π/3, x coordinate. Sine 5π/3, y coordinate. Tangent, sine over cosine, negative radical 3/2 divided by half. Play that game, just lose the halves, divide by 2. So it's negative 3/1, negative radical 3. And then I just flip. Flip, flip, flip. So the flip of this is 2. Flip of this is negative 2 over radical 3. You can leave it like that. Flip that, negative 1 over radical 3. Okay. So that is that. Okay, then starting with number 9, find the values of all the trig functions from the given information. So they tell you some stuff. And what do I do with that stuff? Okay, so number 9, cosine of t is 3/5. I'm in quadrant 1. Okay, some identities that we'll need. So here's my little memory trick again. All students take calculus. I'm not going to write that down because the main thing is all functions are positive. Sine is positive, tangent positive, cosine positive. And there's some identities that you need. And you can put these on your formula sheet. Cosine squared t plus sine squared t is always equal to 1. Here's a couple other identities that you might remember from trig, but you can put these on your cheat sheet. 1 plus tangent squared t is secant squared t. 1 plus cotangent squared t is equal to cosecant squared t. And that's not hard to show. Let's see from here. If you divide both sides by cosine squared, you get this. And from here, if you divide both sides by sine squared, you get this. Okay. I won't bother to show it to you, but you've seen this before, no doubt. So I would advise put this on your formula sheet. Cosine squared t plus sine squared t equals 1. And these two also put in your cheat sheet. 1 plus tangent squared is secant squared. 1 plus cotangent squared, cosecant squared. Okay. Okay, now, if they tell me I'm in quadrant 1, that's my best case scenario. Everything's positive, right? So use cosine squared t plus sine squared t is 1. Cosine t, they tell me is 3/5. So 3/5 squared plus sine squared t is 1. 3/5 squared is 9/25. Subtract 1 in the form of 25/25. 25/25 minus 9/25 is 16/25. So 16/25 is sine squared t to the square root. Normally you would do plus or minus. That's why I have to figure out what quadrant I'm in. Quadrant 1, everything is positive. So sine of t is 4/5. Once I have these two, the rest pretty much fall into place. Tangent t is sine over cosine. 4/5 divided by 3/5. You'll see this theme happening over and over and over again where you're dividing by the same thing. Just cross off those 5s, so you have 4/3. All right, see 4/5 divided by 3/5. Knock out the 5s, 4/3. And then the reciprocal. Reciprocal of cosine, cosine, there's a co. So the reciprocal does not have a cosecant. So flip it, 5/3. Cosecant, there's a co. Reciprocal does not have a cosine. So I flip sine 5/4. Reciprocal of tangent, cotangent. So 4/3, 3/4. And there we go. All right, so if they give me either cosine or sine, like 9, 10, 11, 12, use this, cosine squared plus sine squared equals 1. If they give me any of the other trig functions, tangent, secant, cosecant, cotangent, then what you do is use, you basically use whatever formula that they give us information for, right? So like 13, tangent of t is 2. T is between 0 and pi over 2. That means I'm in quadrant 1. Then I use these identities. 1 plus tangent squared t, secant squared t. Okay, so 1 plus 2 squared, right? Tangent of t is 2, 2 squared, secant squared. 1 plus 4 is 5. 5 equals secant squared of t. Take the square root. Normally I do plus or minus, but I'm in quadrant 1. So secant of t is radical 5. So that's finished. Okay. Then I reciprocate. Cosine of t is the reciprocal of that, 1 over radical 5. And yeah, obviously, if the tangent of t is 2, cotangent is 1/2. Okay, so I got tangent, cotangent, secant, and cosine. So I need sine. Well, once I have this, I can go back and find the sine by using this here. So that's what I'll do. So sine squared plus cosine squared is 1. Sine squared plus cosine 1 over radical 5 squared equals 1. 1 over radical 5 squared is 1/5. So sine squared of t plus 1/5 is 1. Subtract 1/5, I get sine squared of t is 4/5. The square root of both sides. I don't have to do plus or minus because I'm in quadrant 1. So sine of t is square root of 4 is 2. So 2 over radical 5. And therefore cosecant, flip it, radical 5 over 2. And there we go. All right, so that is that. I'm going to talk a little bit now about the graphs of the other trig functions. Okay, so the graph of the tangent function, figure 3, on page 234. Well, tangent is sine over cosine. So if I look back at a table of sine and cosine, page 232, we've got all of these here. So sine over cosine, 0 divided by 1, 0. 1/2 divided by radical 3 over 2, cross off the 2's. 1 over radical 3 or radical 3 over t. Pi over 4, that divided by that is 1. That divided by that is radical 3. 1 divided by 0 is undefined. Okay, so between 0 and pi over 2, I've got 0 goes to the, so tangent goes to the origin. At pi over 4, the y value is 1, and then it becomes infinite. It goes to infinity. So that means here's 0, 0, pi over 4, comma 1. Pi over 2, I have a vertical asymptote and it shoots up. Now, tangent turns out to be an odd function. Tangent of negative x is the opposite of tangent of x. So I have symmetry with respect to the origin. So once I have this, I'm trying to get my fingers here. Once I've established this, if I reflect across the origin, I get this. So right now I have that one branch right there between negative pi over 2 and pi over 2. That is one period. Notice the rest of the graph just repeats. So the period is pi for the tangent function. So unlike the sine and cosine, which have a period of 2 pi, the tangent has a period of pi. Between negative pi over 2 and pi over 2, that's pi units. If you take upper minus lower, pi minus a minus pi over 2, that's pi over 2 plus pi over 2, which is 2 pi over 2, or pi. And then you can just copy and paste. So copy, paste, 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 paste. So you have these things that keep going like that all the way through for a tangent. So notice it's always increasing function all the way throughout. Period is pi. All right, and then with all the trig functions, we're going to do the usual stuff, right? Translate left, right, up or down, right? Change the period and so forth. So we'll learn how to do that in a little bit. But now that we have the graph of the tangent looking like this, by the way, if you want to put that on your cheat sheet, you may. Sample of the cosine, sine, and tangent graphs. And so it's very unlikely on a test or quiz, I would ask you to graph literally just sine, cosine, tangent. You're going to have to do something to it. Move it left, right, up, down, stretch, shrink, all that stuff. Okay. And now, how about secant, cosecant, and cotangent? Well, those are just reciprocal functions. So remember, we did a while back the rules for reciprocal functions, right? And we'll just piggyback on what we learned back there for the reciprocal functions. Here we go. Okay, cosecant, page 236. Okay, so sine function is in blue. Here is one period. So sine, 0, maximum, 0, minimum, 0. Maximum, minimum are 1 and negative 1. Or more strictly speaking, midline, maximum, midline, minimum, midline. But here the midline is 0. Okay, so how did I come up with the red graph? Simple, follow our rules for reciprocals that we said before. Where is the cosecant undefined? Wherever the sign is 0, because 0 has no reciprocal. We said that before when we did reciprocals, right? So right there, and right there, they touch the x-axis. So undefined, asymptote, asymptote, asymptote. So x equals 0, x equals pi, x equals 2 pi, undefined. They become vertical asymptotes, right? Then we said, whenever the function is 1 or negative 1, they match. So the graphs match here, and here, and here, and so on. Right? The reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. So they match here. And then we said, okay, they're the same sign, SIGN. So wherever the SINE is positive, the cosecant is also positive. So notice both the red and the blue are above the x-axis. Both the red and the blue are below the x-axis. Right? The reciprocal of a positive is positive. The reciprocal of a negative is negative. And then we play the game. If one increases, the other decreases, right? So if I look at the blue graph, decreases, therefore increases. Going right to left, decreases, increases. So it's kind of U-shaped. And right over here, yeah, let me get this quickly. And then, so here, increases, therefore decreases. And over here, increases, so decreases. So for cosecant and secant, you get a bunch of these. Upside U-shape, upside down U-shape, upside down U-shape, and so on. So if you keep going, you see a whole bunch of these. And likewise for secant. Yeah, question.
On an exam, like I graph these by I'm doing like a dashed line of sine and cosine, and then adding in the would you want us to keep like the dashed line there or just have only this cosecant and secant graph?
Okay, so the dashed line, that's up to you. Even if you keep
I
it
mean,
solid,
yeah, like,
I know what you're
yeah.
doing.
Okay, great. Thank
I'll
you.
accept it either way. Okay. All right. And secant, something similar happens. So here's one period of the cosine function. So if you can just ignore the red, I know it's hard to do when you got, maybe I should go like this. The blue is cosine. Yeah, don't even look at the red. Okay. So cosine goes maximum, midline, in this case it's 0, minimum, midline. Oops, where'd I go? And then maximum, right? Maximum right over here. Into more than one period there. Okay, so one period is right here. Okay, so same principle. Where is the cosine equal to 0? There and there. Reciprocal of 0 is undefined, so vertical asymptotes. Where will the cosine and the secant match? At 1 and -1. 1 and -1, they match. And then same game as before. Here, decreasing, increasing. Going from right to left, decreasing, increasing. Increasing, decreasing, increasing, decreasing. From here, whoops, decreasing, increasing, decreasing, increasing. When one goes up, the other goes down automatically. And so once again, automatically, secant also, so both secant and cosecant go like this. U shape, upside down, U shape, U shape, upside down, U shape, U shape, upside down. Okay, for one period, maybe I should go like this. That's one period, that's one period. So the period is 2 pi for secant and cosecant. Okay, so maybe I'd make a little mini table here. Period. What has period 2 pi? Sine, cosine, cosecant, and secant. Period of only pi is tangent, cotangent. Okay, so regular sine and cosine have periods of 2 pi, and therefore so do the reciprocals, cosecant and secant. But for tangent and cotangent, the period is only pi. Okay, now what about here? We've got all these lines all over the place. So let's see, I guess that's the yellow line is tangent. So we already analyzed tangent back over here. If you're following along the text, it's on page 234. Okay, so look at only the yellow, if possible. Okay, and now how do they come up with the green cotangent? Okay, so follow the same principle. If the tangent is 0, like there, so yellow touches the x-axis, yellow touches the x-axis, yellow touches the x-axis, yellow touches the x-axis. For the cotangent, undefined. So notice right here, well, they didn't draw it because the y-axis here, but vertical asymptote. Vertical asymptote, vertical asymptote. Okay, the graphs match at 1 and -1, 1, -1, and so on. And then just do the increasing, decreasing game. Your tangent from here increases, decreases. If I go this way, decreases, increases. If I have here -1 for the, let's see, the yellow graph increases, decreases. If I go from right to left, decreases, increases. So cotangent, get a lot of this stuff. So real quick idea for tangent. Tangent, you get a lot of this stuff. All going up. Cotangent, all kind of going down. You get a lot of this stuff for cotangent. And again, you're welcome to put these on your formula sheet, a basic graph of each of these functions. And then once again, we're going to do stuff to these graphs, right? From our basic graphs, we're going to stretch it, shrink it, move it left, right, up, down, all that good stuff. Okay. All right, but this was just about all I was going to do for today. I'll just tell you where we're headed. So tomorrow, I'll continue doing some more of these problems, and then we'll work on some of these graphs over here. So we're on the 4.6, and let's see, we're on this side. Guess I'm a little bit ahead. Okay, so tomorrow I'll give you a quiz on trig, due at 11:59 p.m. again. That shouldn't be too bad. So on the stuff that we've been doing the last several days, is probably the best way for me to say it. Okay, so I'm done for the day, folks. 9:45-ish. So let me stop the share and see if anybody has any questions. Let me check the chat. Okay, I don't see anything in the chat. Okay, 4.5, number 9 is asked for. Let's see what that's about. Okay, 4.5, number 9. Here. 4.5, number 9. Y equals -3 cosine pi x. Okay. Share the screen. Okay, so the amplitude is 1. Period is 2 pi divided by b. 2 pi divided by pi is 2. That's nice. By the way, that's a common theme. To get nice numbers without the pi, then the b involves a pi like this, and you just get nice numbers like 1, 2, 3, 4. And I have a shift 3 down. Okay, so let's talk about so 1 period is 2. So 1 period, I'm going from 0 to 2. My range, amplitude is 1. So I normally go from -1 to 1, but I'm subtracting 3. So -1, 1 minus 3 is -4, -2. And since I went 3 down, midline is y equals -3. Looks like. Okay. So 1 period goes out to 2. Cut that in half. 1. Cut that in half. 1/2. And 1.5. And -1, 2, 3, 4. With the midline of y equals -3. This is like a new 0, so to speak. And I'm doing cosine. There's no negative in front of the cosine. So cosine goes maximum, midline, minimum, midline, maximum. So that should do it. Okay. And we double check some stuff. I plug in 0. Cosine of 0 is 1, minus 3 is -2. That's correct. I plug in 1. Cosine of pi is -1 minus 3 is -4. That's correct. I plug in a half, cosine of pi over 2 is 0. 0 minus b is negative. Yeah, so seems to work. All right, any other questions, please? All right, that'll do it for today, folks. All right, so have a good day, and we'll see you tomorrow. Give you a quiz tomorrow also. All right, bye, everyone.
Thank you.